First of all, a very good afternoon to everyone, all the participants who are present over here. Myself, Vishal Raut. I am an EV trainer at ISI India Private Limited, currently there at Orissa. Today we'll have our virtual webinar on electric vehicle battery from chemistry to manufacturing, where we're going to cover a lot of aspects that what are the various chemical or chemical aspects as far as EV batteries are. Test we can perform onto the cells such that we can able to calculate, we can able to understand the nature of the cells, right? If I'm talking about a battery or a cell, I wanted to understand from the participant itself, means when I'm talking about the cell, when I'm talking about the battery, what participant used to understand means if I'm talking about specific definitions of it, someone has unmuted himself. Sir, I hope someone has unmuted himself. It will be better. Thank you. So I wanted to have a words from the participant. Can you please do let me know what exactly do you understand the term called as battery? Just give me a moment. Let me share once again my screen because just give me. Let me share once again the screen. I hope my screen is visible to all of you. Yeah. Can any participant do let me know when I'm talking about a battery, what do you understand by the term called as battery? Any participant from your side? Any participant who can able? We can develop it as a voltage sources as well. Great, great. Okay, fine. All of you are perfectly right at your own places when I'm talking about a battery or a cell. Sometimes we use this particular term interchangeably. Yes, it's a power sources, right? So sometimes we will change this particular thing interchangeably. Why we are change this particular cell and battery interchangeably? Because we have to understand from what exactly the cell and from how the battery pack is being manufactured, right? If I'm talking about a battery pack where the power is been given to the complete vehicles, for example, in case of an electric vehicle, where the power is been given to the complete vehicle, so we are utilizing the complete battery pack for that purpose. That battery pack is not a single battery or it's not a single entity. That is the combinations of multiple cells, even the combinations of multiple modules are being there. And ultimately, we have some electrical connections from that battery pack. And finally, we are giving the power to the complete vehicle. And that is how the things is being happening inside a complete vehicle, right? So that thing we will going to study in this particular lecture or in this particular 2 hours webinar, that how the chemical aspects of the battery is actually being vary from different cells to cells, why the different cells will going to create, some cells are going to create lesser amount of voltage, why the lithium ion cells will going to create higher amount of voltage, what is the reason that lithium ion cell is now being on the top of the notch, because of which lithium ion cell is keep on evolving, right? And the related supply chains is also hampering if something happens in the geopolitical tensions and the geopolitical scenarios, right? So that all aspects we're going to cover in this 2 hours webinar. Along with that, we're going to see I had in front of me the grader. We are going to see the parameter of the complete battery pack. We have 8 channel cell grading machines in front of me. So we're going to see that if we wanted to perform various tests on the particular cell, if you wanted to design an equivalent circuit of the cell, or if you want to design, or if you want to test the cell at different C rate, whether the cell is performing up to the mark, up to the capacity mark. So it will be possible. So how do we can able to set that parameters? So I had everything in front of me. So towards the end, means after the end of nearly around 1 hour, we'll go for that particular thing, that capacity testing, or hyper pulse power characterization testing, how to set test parameters inside a system. We're going to look into it, right? So let us start from the battery. That we all know battery is a device which is consisting of one or more electrochemical cells, right? And one or more electrochemical cells are actually convert the electrical energy, or convert the stored chemical energy into the electrical energy, and they are directly powering those devices, right? And we all know, because our battery is a power source which will going to give the direct current, right? So in order to get an alternating current from the battery pack, we have to connect some power electronics converter block in between, which we are calling them as an inverter, right? So as we are utilizing in our home as well, lead acid battery. So lead acid battery is not directly powering our home appliances. That's why we are connecting something called as inverter, and inside the inverter there are a lot of switches are being there, whether it is IGBT led inverters or the MOSFETs led inverter. So the switches are being there, and by varying the switching frequency, by switching the MOSFETs and IGBT, we are actually convert that current into the alternating current. Then we are providing it to our home. So this we all know that is the normal things that we all know. Right, and battery is being used in majority of applications, even used from your mobile phones, even used for your hand watches, even used for the laptops where I'm currently teaching you, even used for various other machinery equipments. So battery is one of the very biggest market as far as world has been concerned, and understanding the chemistry and understanding the manufacturing process of it will also gain a huge impact on that particular manufacturing unit. So when I'm talking about a specific battery, so sometimes people are getting confused that battery is a topic of electrical engineers, battery is a topic of mechanical engineers, battery is a topic of chemical engineers, but it is a topic where multiple discipline comes into actions, right? Because it is not a topic that only electrical or only chemical or only mechanical engineers will going to do it, but it is a multidisciplinary domain, right? For example, if I'm talking about understanding the nature of the chemistry which we are using inside a cell, it is something which is a job role and which is a domain of a chemical engineer system concept. Understanding the mechanical design of the complete battery pack, understanding the thermal management of the complete battery pack, understanding or integrations of the thermal management of the complete battery pack, it is somewhat comes under the mechanical aspects of the design parameters of the battery pack, right? Because mechanical engineers would know more than us that how to design a thermal aspects of it, what must be the coolant can be taken inside a battery pack such that that coolant will give us a lot of amount of efficiencies. Nowadays people are working on nanofluids, right? So research is going on the nanofluids for the cooling purposes. So multiple things are being there, which is a part and parcel of a mechanical engineers are being there. Then as an electrical engineers, the output of the battery is something which the electrical engineers were more focused about, because we are concerning on the output side of a battery pack, because we'll use those output and we're going to use that output in powering some devices or increasing the output or using some electrical equipment. Likewise, the electrical engineers comes into account. So it is not a domain of a single engineering entity of the single engineering domain, but it is the domain of a multiple disciplines. Multiple disciplines, when they're going to combine, ultimately will create a bigger subject, which is nothing but called as battery. That's why everywhere you can see battery is not a single discipline, it is a multidisciplinary domain, basically, if I'm talking about, right? So you can see the images, the Duracells, that are the cells. Then after that, you will see the combinations of the cells. Then after that, we can see a complete pack, which is a part and parcel of a 4-pillar battery pack, right? So let us move to the front. Then we have something, always we are utilizing interchangeably term cells. We have something interchangeably use the module. We have something interchangeably use the pack. So we all know that first of all, we wanted to know that what exactly a cell, when I'm talking about a cell, what exactly that cell was. When I'm talking about a module, what exactly that module was all about. When I'm talking about a pack, what exactly that pack was all about. So whenever I'm talking about a cell, so cell is that smallest device whose work is to generate the energy. For example, if I'm talking about our complete body, so our complete body is being made up of a single cell only. So the cells are being connected, the cells are being divided themselves by the process of meiosis, mitosis, and ultimately they led to the creation of some tissues. Then tissues are being combined, led to the creation of muscle are combined, led to the creation of organ are combined, led to the creation of organ system, multiple organ system combined, led to the creation of a complete body. Right. Likewise, cell is the smallest electrochemical device. Cell is that smallest electrochemical device which ultimately connect in series or in parallel or in the combination of a series and parallel to create two things. One, either they can lead to the creation of a module. Second, either they can lead to the creation of a battery pack. Now the question comes: always the students or always the persons or the manufacturers is used to take this particular module or pack interchangeably. Means they can even call a pack as a module, they can even call a module as a pack. But whenever I'm talking about your equipment, let us suppose we'll understand by a simple example. Let us suppose we have two vehicles. Let us suppose this is A vehicle, this is B vehicle. And let us suppose we wanted to power them by utilizing a 48-volt battery. We wanted to power them, right? So if you wanted to power them, let us suppose this A won't require a 48-volt for the powering purposes. This B is required 96-volt for the powering purposes. Means I'm not going into the capacity terms yet. I'm just saying A is requiring 48-volt for power purposes. B is requiring 96-volt for the purposes of the power. Now the question comes, if A is requiring 48-volt, B is requiring 96-volt, so how can we do? Let us suppose we have only the battery pack of 48-volt. We have 3 48-volt battery pack. This is nothing but one battery, this is another battery, this is another battery. Means here the cells are been combined and led to the creation of a battery. Here again the cells are been combined, led to the creation of a battery. And again here the cells are been combined in series and parallel and they led to the create a particular battery. Now a question comes, let us suppose I wanted to power this particular A battery. I wanted to power this A vehicle. So how will I connect? I will connect a complete 48-volt battery pack to this particular A and I can able to power this A particular A. Now let us suppose I wanted to power this B. So how do I can able to power this B? How do I can able to power this particular B? We will going to connect. How do I able to power this particular B? We will going to connect this two battery in series. We are going to connect these two battery in series, right? If I'll connect 48-volt and 48-volt in series, so in series we know the voltage remain added. So what we'll get? We'll get 96-volt in terms of the battery pack. We'll get 96-volt. Now to power this B battery, to power this B equipment, exactly the series combination of the two unit, exactly. So to power this to B unit or the B vehicle, how much battery we had been used? That is nothing but 2 units of a battery. And each unit is nothing but called to be as a module. This each unit is nothing but called to be as a module. Each unit is nothing but called to be as a module, right? So 2 modules are interconnected and they led to the creation of a complete battery pack, and then they will actually power this device or power this vehicle. Means what we are doing, we have connected the 2 modules, and from that module we have created a battery pack. And the question comes, how this module are being manufactured? This module are being manufactured by the combinations of cells in series or in parallel, or in the combination of them, right? So modules is created by the combinations of cells. Battery pack is being created by the combinations of a module. So there are generally 3 approaches which the manufacturer is being utilizing. Either they are going for cell to battery pack approach. They will skip this module term. They will directly go from cell to battery pack approach. They will go from cell to module to battery pack approach. Cell to module to battery pack approach. Right. So these are the 2 entities which you can able to see in majority of the times in an electric vehicle. Right. This thing you will majorly be seen 4-wheeler vehicles, and this particular thing we can able to see in 2-wheeler vehicles. Generally, if I'm talking about 2-wheelers and 3-wheelers, they are actually go for this configuration where they will go for a cell to battery pack approach. Whenever I am talking about the four-wheeler manufacturer, they will always try to prepare a module from a particular cell they will use in a particular battery, right? In the very first slide, you can able to see the diagram. Just keep your word. Just to up. In a very first slide, we can able to see this diagram. You can see this diagram. So this is nothing but a multiple modules have been connected, and each modules is nothing but the combination of multiple cells. So multiple cells are being combined, then led to the creation of a single module, and multiple modules are being combined and then led to the creation of a complete battery pack. Now there is a question: why the four-wheeler manufacturers is opting for a cell to module approach and then module to battery pack approach? Why two-wheeler is not going for a cell to module and module to battery pack approach? Why they are manufacturing directly cell to the battery pack? There is a reason behind it. Because whenever I'm talking, there is a reason behind it. Whenever I request to all the participants, means I will give you the time for the doubts. If you have any doubts in the middle, means you just write it up. After the completion of certain topics in advance, then we will take some doubt. That will be better, I guess. We can able to complete our lectures, we can able to complete our webinars, and also the efficiency will be increased, right? So at the end also you can able to ask me whatsoever is being doubt is being there, so I can able to clear and figure it out for you as well. But we will take the doubt after certain completion of the classes. That will be the better approach. I hope you can able to understand. Fine. So why the two-wheelers will be go majority for cell to battery pack approach? There is a one reason behind it. The reason behind it is they have utilizing a very few cells. That is not they will going to utilize 4,000 and 800, 900 cells. They are utilizing a very small cell, even 100 and 200 cell within that. And managing 100 and 200 cell for a single BMS is not a very bigger task. They can easily able to manage. And apart from that, when I'm talking about the two-wheeler, we don't have haptic systems is being connected with that two-wheeler, like we have an air conditioning system, like we have a huge infotainment system, like we have an airbag control system, like we have an ADAS control system. That thing, haptic thing is not being present in that two-wheeler. Two-wheeler is as simple as possible. If we go for a very advanced two-wheelers as well, they do have some features like automatic balancing control. They do have some features like GPS positioning system, but they won't consume huge amount of power from the complete battery pack. So managing a small amount of cells inside a two-wheeler is quite easy. So BMS algorithm can able to manage that. But when it comes to the four-wheeler, so the dynamics of the four-wheeler is increased a huge increment is being happening in the dynamics of the four-wheeler, because over there we have something called as the charging, over there we have something called as air conditioning system, over there we have something called as generally if I'm talking about a two-wheelers are generally go for air cooling systems. They you will rarely find some two-wheeler will go for liquid cooling or direct refrigerant cooling system, because they require a huge system to be connected inside as a part and partial of a battery pack system. And we don't have that much of space inside a two-wheeler so that we can implement that much huge amount of whether it is DRC or whether it is liquid cooling system inside a battery pack. But in four-wheeler we have a huge space, and in four-wheeler we are actually requiring that kind of huge battery pack, that kind of huge, what I mean to say, that kind of huge cooling systems, whether it is direct refrigerant cooling, whether it is liquid refrigerant cooling. If you go for a direct refrigerant cooling, you need a condenser, you need a compressor. Again, they are going to take certain powers, right? So if that much amount of power is being required, so huge number of cells are to be used. And if huge number of cells are to be used, then definitely we have to use the different BMS for each section. Because one BMS, if that will fail, ultimately a complete battery pack may comes into a danger. It can even happen that, yeah, any doubts? Sorry, anyone is speaking something? Yeah, so what will be happen? Thermal runaway can also occur. That is why we need to manage each module separately. That's why every four-wheeler system, if I'm talking about, they will be off from cell to module to battery pack approach. And for each module, they will be connected one slave battery management system. And each slave battery management system is communicating with a master battery management system, which will be connected above. You can see this particular thing. This is nothing but act as a master battery management system. master BMS, right? And inside each module, you'll find one battery management system. If I can take this as one module, this one BMS is being present, right? And these are nothing but called as slave BMS. And these slave BMS are responsible for managing the cells, which is comes under their directory. It is just like the district. District come under the, if I'm talking about district comes under the collectors. District magistrates are heading the particular district. And district magistrates are reporting to their superior authority who is being seated above it, right? So as in terms of us, if I'm talking about a skill development, so district employment officers are heading the skill development in the district, and they are reporting to the directorate of a particular skill mission who are implementing the directorate level in the state. So this master BMS is actually managing all the things, and the slaves are there which will going to share data with the master battery management system. Slaves cannot be able to activate the cooling system. Cooling system can be activated by the master battery management systems only. Slave only can able to balance the cells which has been comes under their radar. Slaves can able to share the data with the master battery management system. So this kind of approach is called as master to slave BMS integration concept. Right. So the topic is not about as a BMS, but I had explained you because in a four-wheeler we are never utilizing the single BMS. We are opting for a multiple BMS, and multiple BMS is communicating with one single BMS, which is a higher BMS, and that is called as the master BMS. But in case of two-wheeler, we are generally operating with one BMS because implementing more BMS will, because BMS is again an electronic circuit which having a semiconductor unit with having a microcontroller unit, which we use to algorithmize. But using that huge BMS or that multiple BMS in the two-wheeler will ultimately increase the cost. So whenever we are manufacturing the electric vehicle, we have to look for the cost, constant as well. That's why majority of the two-wheeler will never opt for this master slave BMS. They will use one BMS, which algorithm-wise, on the management-wise, they will be best, and ultimately that is managing the complete battery pack. So generally, you can see this particular battery pack, that is actually been opted for the complete, what I mean to say, for the two-wheelers generally is being there. So any doubt up to this, I'm open for it. If anyone have any doubt, you can do let me know. Then we'll sooner we'll continue. It is possible, Shivam, for the a two-wheeler to have a two battery pack that connected in a series. But generally, what is happening, that will take a huge amount of space, and again, the cost will going to be increased. If one battery pack will getting failed, so other will get a lot of stress, and that stress BMS cannot generally manage, right? Means that is, for example, if you design a battery management system, so if you're using two battery pack in a two-wheeler, then you have to algorithmize them in that particular way that if one fails, BMS will automatically cut off the others. Because you can even assume that if one battery pack will fail and the other will be running, so all the load is going to come into that particular battery pack, and it might happen that that particular battery pack will thermally run away. But in case of four-wheeler, we have a specific thermal management system. Even in case of thermal runaway, we can able to implement the thermal management system like liquid and DRC, which is more efficient than the air cooling and air heating systems, which ultimately can able to shut down the battery and keep the battery temperature under the nominal range. So answer is yes, we can use, but we cannot directly use that. If we are using that, then we have to opt for some advanced, battery management system which have good algorithm to maintain that.
Hi Vishal. Actually, I have one confusion because if the battery is connected in series, then there is, let us assume that in our vehicle we need have the 48 volt will be required for vehicle run. And if the battery pack is divided into 24 volt with constant AH will be there. Okay? Then 24 volt is not enough for the, let us assume that one battery pack will be distorted, any defect will be there. Then one battery is not enough to run the vehicles, then how it can be possible for us?
It will never possible because ultimately 24 volt is very lesser. Actually, what is happening, the motor has some minimum voltage for the operating conditions, right? If it was written 48 volt, that is a normal operating voltage of a 48 volt to the motor. But that is not if we'll give 42 volt the motor will not run. That will run, but the speed of the motor will be lesser. right? So what I mean to say, if you are using two battery pack, then you have to use two battery management systems as well, right? Because one system is not able to achieve that much of efficiency in that cases. It might happen if one will be failed, the battery management system get confused with other, because the algorithm, because that is all depend upon your algorithm, what you have to be code for, right? Because we have to protect the battery, and that's why we had connected the battery management system, and we have to connect a proper battery management system such that it can able to handle the amount of current which will be going to be discharged. So rather than going for two battery pack utilizing for 24 and 24, then we have to manufacture its casing, then we have to manufacture a separator in between the two battery pack, and we have to use the two battery management system. We can go for a single cell. For example, if a particular battery pack is being there, which is used for, let us suppose we want let us suppose we want a 48 volt 6 ampere hour battery pack. We want to manufacture a 48 volt and 6 ampere hour battery pack, and we have a cell which is rating of 3.7 volt and 6 ampere hour. So if you wanted to manufacture a 48 volt and 6 ampere hour battery pack, how many cells we need to connect in a series? That means what is the total amount of voltage we want divided by the single cell voltage. That means we approximately require 13 cells in series. So connecting 13 cells will be good. If we are connecting 6 and 7 cells in somewhere, then we have to use two different configuration of the battery management system. Because in one, we have to use 6S BMS. In second, we have to use 7S BMS. And then we have to use another BMS. That indefinitely increase the cost of my vehicle, which is of no use as far as customers and as far as Indian customers is being demanded. Getting?
Yeah, actually, I have one more confusion because most of the two-wheelers vehicles have a 2 or 3 battery pack inbuilt in there. But if you have seen the rating, then their voltage will be constant. So there is no series option they are providing with us. They are generally connected in the parallel of the 3 battery pack and then run 2 vehicles. Because in such scenario, if any one battery is not well working, then 2 battery will be enough to run the vehicle, or 1 battery is also enough to run the vehicle. But the range of the vehicle is might be difficult. Not such given scenario, just like if in starting it's 100 kilometer, now it's just going a 25 kilometer and fully discharge if the 2 battery is not running well. So I think series is not possible in the two-wheeler case because voltage drop will be coming down situation in that.
Yes, you are absolutely right, because in parallel connection we are increasing the capacity. So if we have connected 3 cells or 3 battery pack in parallel, if one could fail, then we can reduce the capacity, but we cannot reduce the voltage generally. But what exactly happen for that? What exactly will be happen in that conditions? Your BMS will means what is happening. See, whenever we are algorithm the BMS, our main function is to protect the battery. Okay, because what will be happen, lithium ion cells, if you go for a chemistry of a lithium ion cell, if it will release a single electron, it will going to generate a 3.7 volt. You can able to imagine it will going to generate a 3.4 volt. That means you can see lithium ion is very, very reactive. And if suddenly one battery can fail and other two will getting certain load, the battery will be getting, that means the things will be there, only thing will going to get the capacity less. But with the 3 battery pack, what amount of current is being absorbed, the same amount of current, now the battery will, means it will increase the accelerator, and that same amount of current is being required. And because of that reason, if BMS won't able to have, and if BMS won't able to manage that thing, and if because of some reason the BMS would fails, then ultimately that will catch a thermal runaway inside your particular vehicle. Right? So that's why I'm telling you, it is all the games of a BMS, because if we design a BMS which can able to handle that much of pressure and all those things. That's why every time we required to manage, means our main focus in terms of battery management system, to make the particular battery safer for the operations of a use. Right? Because when I was designing the battery management system, I will always try to design that the battery pack is more safer. Because if smaller temperature fluctuation is being happen, and in case of two-wheeler, we don't have a specialized dedicated thermal management system, ultimately that will going to impact my battery pack in huge way. It might happen, it catch fire, it might happen, It may take. You heard about the Ola Electric, fire cases, right? What is happening with the Ola Electric fire cases? Because they try to use these things earlier, and ultimately the BMS won't able to sustain that kind of impact, and ultimately they catches the fire, and ultimately what happens.
I think if you are study about the Ola case, Ola is using an MC cell. And if you have know about the characteristic of an MC cells, the working temperature will be up to 35 degrees Celsius. But in Indian northern conditions, we have seen the maximum temperature is, or atmospheric temperature is up to 40 degrees Celsius or 45 degrees Celsius in the summer days.
Yes.
So during that situation, obviously we get the battery is not working well, and cases will be firing in the battery pack in the transport during the transportation, or some cases will be given there.
Yes. But that is something which I wanted to convey, that BMS is play a very vital role in that condition. If you
BMS will be control all the things over to the battery. But in the two-wheeler cases, we have designed on focus on the only parallel basis, because series is not a connection in the battery package or module basis.
Exactly, series is not a options in case of battery pack.
In the battery pack of two-wheeler, four-wheeler, we have to make connected in different battery pack series connected.
That will be happening.
All master BMS will be focused on that. But in the two-wheeler cases, we will not use the master BMS, and it's also difficult for us to maintain 2 or 3 batteries for pack. But I think if you know about the F77 have a 3 battery pack with the 4 AH will be constant for divided into 3 category, but the voltage of the 3 battery pack will be the constant.
Yes.
Yeah. Okay, thank you.
Yeah. Shall we go forward?
Yeah, sure.
Okay. So now we'll go for types of a battery quickly, just to have a look on it. So if we'll go for a chargeability, based on the chargeability factor, the battery has been classified into 2 types. One is primary, another one is the secondary. So whenever I'm talking about a primary battery pack, so those battery pack which are rechargeable, which are non-rechargeable in nature, they are the primary battery pack. And those battery pack which are rechargeable in nature, they are secondary battery pack. So if I'm talking about a primary battery pack, like which we are utilizing in the remote of ours, which is generally we are utilizing for the purpose of TV operations, AC operations, that is nothing but the primary battery pack. And the secondary battery pack is what we are utilizing, that is lithium ion cells, lead acid cells, nickel cadmium, nickel metal hydride cells. There comes under the secondary battery pack, right? So that is based on chargeability, whether we can charge or we cannot charge. On the basis of that, the batteries are been, or the cells are been classified into 2 types, right? Then based on the internal constructions and the electrolyte compositions, the cells are being further classified into 3 types. I'm sorry, there is a typo error over here. It is exactly the 3 types. That is, one is the dry state battery, one is the wet state battery, another one is the solid state battery. If I'm talking about a dry state battery is a particular battery where the electrolyte is being present in the paste rather than the wet format. And in the wet state battery, the electrolyte present in the wet format, right? If I'm focusing about lithium polymer battery, if I'm going to go through about, they are generally considered to be the dry state batteries. If I'm talking because of the presence of polymer electrolyte, if I'm talking about the wet state batteries like LFP, NMCs, they are nothing but called as the wet state batteries, right? And if I'm talking about a solid state battery, that is the new form of battery which is still under the research. It is not being invented and not being utilized in bigger applications as EV, and even in mobile phones also, they are not being utilized in a higher manner. They are still under the research by various companies like Samsung, QuantumScapes, right? So solid state battery is the battery where we are using electrolyte as a solid, and the claim is that they will going to give you the higher energy density compared to wet and dry state battery. Apart from that, they were more safer compared to all other battery chemistry, right? Even if we are utilizing solid state battery for the LFP cells, which is thermally more resistant cells and thermally more intensive cells, So this kind of chemistry can implement the complete battery pack and can able to change the course of the battery pack in terms of safety is been concerned. But solid state battery still is being under the research, and in case of wet state and dry state battery, for example, if I'm talking about a cylindrical cell, so first we will take a cover of electrode, positive electrode, then we'll take a cover of a separator, then we will take a cover of a negative electrode, right? So separator is act as an insulation material between the two electrodes. But in case of solid state batteries, we don't require any kind of separator, because electrolyte itself will be act as a separator. It won't allow any flow of electrons through it, right? So these are the different types of battery as far as electrolyte composition, as far as internal constructions is being there. So these are the three states, or these are the three types of batteries being there based on what electrolyte concentration are being there. Then we have something called as the usage of a EV battery, which has been classified into two types. Generally, if I'm talking about a traction battery and an auxiliary battery pack, right? So generally, traction battery is a battery pack which is used for the propulsion unit of a complete vehicle. If we are powering the traction motors, if we are powering the complete propulsion unit of a vehicle, because of which the vehicle is been moving, that particular cell or that particular pack is nothing but called as the traction battery pack. And powering the auxiliary equipment which is being present inside the vehicles, like infotainment system, like lights, like horns, like indicators, like smaller, which is requiring very low voltage for the working purposes. Generally, that has been done by the auxiliary battery pack. If I'm talking about the auxiliary battery pack, generally in a four-wheeler, they are of the 12 volt. Even you can see MG Comet, even you can see the Tata Nexon. The auxiliary battery pack is generally of the 12 volt. And if I'm talking about the traction battery pack, they are generally of the higher voltage, right? Higher voltage means they have higher voltage like 48 volt, 72 volt, 60 volt, 100 volt, 120 volt, likewise 200 volt, they will be goes on. Traction battery pack, if I'm talking about. Generally, if you can see the wire color combinations of the traction battery pack, so all the orange color wires is actually comes from this traction battery pack only, right? And auxiliary battery pack, they will be generally present in the front panel, in the front bonnet of the vehicle, right? And their work is to give, generally that auxiliary battery, if I'm talking about, they are higher in terms of capacity, but lower in terms of the, what I mean to say, voltage. They are generally of 12 volt and having a higher capacity. But if I'm talking about the traction battery pack, they are generally of higher voltage as well as they are generally of a higher capacity as well. Right. So traction battery pack, the main purpose of the traction battery pack is to powering the propulsion unit of the complete battery of the complete vehicle, and auxiliary battery pack is to power the auxiliary equipment of the complete vehicle. If I'm talking about two-wheelers, generally in the two-wheelers you cannot find an auxiliary battery pack connected. Why in two-wheelers auxiliary battery pack is not common? Because two-wheeler we have limited space, limited constraint is being there. So generally what we are utilizing a traction battery pack, and utilizing those traction battery pack, we are powering the motors only, right? And now the question comes, how do we going to power the other auxiliary equipment which is being present inside a two-wheeler? So there, for that, again, we are going to use the power electronics converters, right? While doing the wiring connections, we'll do the power electronics converter connected, and power electronics converter will going to convert the high voltage into the low voltage, and then it will going to supply other auxiliary equipment. And generally the buck converter is being used inside that. If I'm talking about an EV, if I'm talking about an power electronics converter, generally the buck converter is being used inside that. So these are the two types of battery pack which is being used. Generally you will see this auxiliary battery pack, they are being used in the four-wheeler generally, because four-wheeler we have huge space, four-wheeler we have multiple equipment, so giving pressure to the one complete battery pack will ultimately decrease the life, the cycles of the complete battery pack. That is the reason why we are utilizing the auxiliary battery pack in the four-wheeler. But in two-wheeler, due to space constraint, we have to use the traction battery pack, only one battery pack, and we can use a smaller power electronics converter which can convert higher voltage into the lower voltage, generally which we are calling as a buck converter, and we can able to power the auxiliary battery, auxiliary equipments of the complete vehicles, right? So if you go for a chemistry of, if you go for a chemistry of components of a battery pack, so prior to go for a chemistry, we have to look for, we have to look for what are the various components of the complete cell is concerned, right? What are the various connections the complete cell is been concerned, right? So if I'm talking about the components of the complete cell, so these are the 5 components of the complete cell which you will generally find in case of an cell is being there. So one is anode, another one is cathode, one is electrolyte, another one is separator, and last one is the electrodes, right? So there is something which is called as the current collectors. Generally, the current collectors are made up of the copper and the aluminum. And above that current collectors only, we have something called as the paste of electrode, right? And if I'm talking about an anode and cathode, so anode and cathode will be not fixed. If I can ask you, anode is negative, cathode is positive, or the vice versa, cathode is negative, anode is positive. So that is not there. Anode and cathode will be depend upon where the oxidations and where the reductions are actually taking place. Okay, we cannot determine them that negative is an anode and positive is an cathode, or the vice versa, positive is an anode and negative is a cathode, right? So we cannot determine that. But in case of primary battery, which is generally non-rechargeable in nature, at that point we can able to purchase it. Once we are going to use, we can discharge it, then we can throw it out. So the positive will be always acting as an cathode. Cathode. The negative will be always acting as an anode, right? So these are the components of the battery. Let us deep dive into the components a bit. Right, if I'm talking about the electrolyte, of a battery pack, so electrolyte is act as a medium. If I can draw it over here, just give me a moment. If I can draw it over here, let us suppose this is nothing but the bucket, kind of a cell can. So inside that, we're going to dip 2 electrode. Inside that, we're going to dip 2 electrode. Right, and that 2 electrode is being dipped inside a electrolyte. That 2 electrode is being dipped inside a electrolyte, right? So this electrolyte will be act as a medium which allow the flow of ions, right? And which will restrict the flow of electrons. Means it will not allow any flow of electrons. It will only allow the flow of ions. So ions can be moved from one electrode, and ions can be moved towards the another electrode, and it will not allow any flow of an electrons inside the electrolyte. And we have to take that kind of an electrolyte as well. So that is why we can say electrolyte is a medium which can allow the flow of ions, but it cannot allow the flow of any electrons between that particular thing. Because if electrons would have flow from here, it will automatically become short circuited, and internally the reaction will be taking place, and ultimately the cell become heated, and ultimately the cell will getting blasted. Right? If I'm talking about the properties of an electrolyte, so electrolyte having a good property that they have strong ionic conductivity, right? Hence they can able to conduct ions more swiftly. They have low electrical conductivity. That means we cannot take an electrolyte which can able to allow the electrical conductions. They have non-reactivity with the electrode materials. For example, if we take an electrode which started to react with an electrode materials, then ultimately the internal reaction will keep the electrode to some different material, and we don't want that reaction should be taken place between the electrode and the electrolyte. And apart from that, if a cell will going to charge and discharge, then ultimately temperature fluctuations is being there. And as electrolyte is present in a liquid medium or in a dry medium or in a solid medium, so definitely because of temperature fluctuation, they will also going to compact, shrink, or they will also going to expand. Because of multiple compaction and expansion, they might lose some of their properties. That's why we have to use an electrolyte which can resist to more fluctuations generally, right? Then we have something called as safeness in handling. We will going to take an electrolyte which is more safe as far as handling is been concerned, right? We cannot take an electrolyte. To handle that, we have to use huge amount of safety layers, right? For example, in my hand, if I take a lithium-ion battery, so inside the lithium-ion battery also there is an electrolyte which is made up of EC and DMC along with LiPF6, right? So if I can do something that if I can take and shake the lithium-ion cell, if I can throw the lithium-ion cell to the top, and if I can able to catch, nothing will be happening. That means the electrolyte which is being used inside this particular cell, it is being very, very safe in case of handling. It is not like that it will came out from the cell and it will be split over my hands. It will never happen. Again, we have to take an electrolyte which is of low cost. We cannot take an electrolyte which is of higher cost. Then again, if I'm talking about an electrolyte, is the combination of salt, it is the combination of acid and the alkalis in water. So salt plus water combination can be, salt plus solvent combination can be possible. sulfuric acid plus water combination can be possible. And KOH, if I'm talking about KOH, is nothing but potassium hydroxide, which is an alkali plus water combinations is also possible, right? So it is an aqueous solution which consists of salt plus solvent, which consists of acid plus water, which consists of alkali plus. So these are the various combinations which is possible as far as aqueous solution of electrolyte is been concerned. They can be used as an electrolyte. If I'm talking about where this particular electrolyte is being used, they're used in lithium ion cell. We'll see this. Where this particular electrolyte is being used, they are used in lead acid battery. Right? Where these alkali cells are being used, they are used in nickel metal hydride. They are used in nickel cadmium battery. Even we are utilizing something called as AA, AAA batteries, right? AA, AAA cells we are utilizing. So inside, as a primary cells, inside this also we are utilizing something called alkali, which is nothing but KOH plus water combination, right? So alkali cells, these are the three kind of electrolyte which we are utilizing inside a battery is been consumed, right? Then if I'm talking about a separator is something which will act as an insulation material between the negative and the positive electrode. Generally, if I'm talking about a separator is made up of polyethylene or polypropylene material, right? Because they will generally prevent any kind of short circuit between the positive and the negative electrode in the electrochemical cell. Because just suppose this is the cell, if we'll roll the cell, first what will be happen? First this green color plate will become, if we don't have any separator, what will become? The brown color plate will become, and if let us suppose we don't have separator, so these two things will touch each other. And if these two things will touch each other, then ultimately that led to the creation of a short circuit. And if short circuit will be happen, ultimately my battery will get in one. That's why I have to place a separator in between. But this separator characteristic should not be like if we place a separator in between, so the separator will block the flow of ions as well, right? That's why we have to carefully select the separator, because if you take a separator which block the flow of ions, then ultimately the separator will going to impact my charging and discharging process. That's why I need to take a separator which allow the flow of ions, but it won't allow any flow of electrical charge, or it won't allow any physical contact between a positive and the negative electrode inside an electrochemicals. Right? Then this is something electrodes which we are manufactured. This electrode is something which we are actually manufactured. Right? In the further slide, we'll have a manufacturing. In the further slide, we will see that how the lithium ion electrodes is actually in manufacturing, what are the process they are following in order to manufacture an electrode is been concerned, right? So electrode is just like an electrical conductor, and electrode is having those active materials which will take part in the chemical reaction, and ultimately will going to create, which will take part in a chemical reaction, and ultimately will going to create an electrical energy from that, because that electrode will be made up of one chemical, the negative electrode is again made up of another chemical or another metal, right? So when we're going to charge them, then some chemical reaction will going to happen in between. Then when we're going to discharge them, another chemical reaction will going to happen in between, because of which one during charging and during discharging, they will release some ions, and if the ions will be moved inside the electrolyte, the electrons started moving from the external circuit, and because of that only the battery will be able to produce the electricity, right? So when the electrode materials is been converted, for example, we have manufactured electrode with X and another electrode with X1. Let us suppose if electrode material is been converted from X to Y, and this has been converted from X1 to Y1, and in this process, what will be happen? My complete electrochemical process will be stopped. Then again, I have to put this particular thing in charge. So what will happen? This Y need to be converted back into the X, and this Y1 also need to convert it back into the X1, right? And if this means this Y1 is need to be converted back into the X1. So this need to be happen, then we can call this cells as a rechargeable cells. Let us suppose if X1 is been converted into Y1 and X is been converted into the Y, and this reverse reaction is not possible. That kind of cells are nothing but called as the primary cells or non-rechargeable cells. So you just need to remember that thing as well, right? And that is the reason that why primary cells are non-rechargeable in nature, why secondary cells are rechargeable in nature. If I'm talking about the primary cells, that is initially been developed in 1800s by the scientist named as Alejandro Volta. initially he had developed something called as the voltaic pile, which is made up of zinc and carbon. And once the zinc will release electrons, slowly and slowly zinc getting shaded out, slowly and slowly zinc getting finished, and ultimately if the zinc is getting decomposed inside the electrolyte, then we cannot recreate that zinc particular again, right? So whatever the material which the Alejandro Volta has made, that is called as zinc copper cell. That is called as zinc copper cell, right? So all the primary batteries, if you can see, they are somehow utilize this zinc. And once the zinc is been shredded, or once the zinc is being decomposed into the electrolyte, then creating the zinc again is a very difficult task for us, right? And that is the reason why all the primary batteries are non-rechargeable in nature generally. And if I'm talking, because here what is being happening here, decomposition reaction is being happening. What kind of reaction is being happening over here? Decomposition reaction is being happening over here. When I'm talking about the secondary batteries, you can see in the secondary batteries, the reaction which is being happening, that is nothing but called as conversion reaction. In secondary batteries, we had changed the material such that while discharging, they will be converted to some other material, and while charging, they will be again converted back from that material to the initial material. You will see one primary battery reactions, what will be happening over there, and you will see one secondary battery reaction, what will be happening over there. Right? One secondary battery means will go for the lead acid and the lithium-ion battery. You will see that particular. Right? And this anode and cathode is something. Anode is something which is very famous for losing electrons. So, in two electrode, at whatever time, for example, when you are discharging the cell, or for example, you are charging the cell. Let us suppose during the discharging, if negative is losing electron and positive is gaining electron, because one will lose, so another will gain. So in that case, what will be happen? Negative will be acting as an anode, and positive will be acting as a cathode. In the vice versa, during charging, if positive is losing electron and negative is gaining electron, at that time positive will be act as an anode and negative will be act as a cathode. Why? Because anode and cathode is based on which one is losing an electron. Those electrons which lose electron, where the oxidation takes place, that is nothing but called as an oxidation reaction. Those electrons which is where the gaining of electron is being happening, that is nothing but called as the cathode electrode, right? So that's why you can see the electrode, we'll see the electrode manufacturing process. This will be more clear to all of you, right? So you can see always if we want that anode oxidation should be taken place, so we need a good reducing agent such that it can take all the electron from that. It can easily lose the electron, and oxidizing agent is being there in cathode, which can easily gain the electrons generally, right? So reducing agent will easily help to lose the electron, and oxidizing agent is something which will allow anything to gain any kind of electron. So that is why you can see these are the four types of secondary batteries which we have generally. So here you can see the lead is being there, you can see the cadmium, metal hydride, and graphite is being there, and in the cathode side you will find lead dioxide, nickel oxyhydroxide, nickel oxyhydroxide, and lithium cobalt oxide. You can see one common thing. What is one common thing? The anode is, here it is not anode actually, here it is something called as negative, and here is something called as positive. So you can see the negative electrode will be always made up of some metallic thing. For example, the metallic cadmium, for example, the lead, for example, the metal hydride, for example, the graphite. They are all the metals, even carbons, graphite is an allotrope of a carbon, right? They are used in a pure format. But if I'm talking about the positive electrode, they are not in a pure format. Instead of that, they are used some oxide format, right? So you will find this thing because of which the reaction, the suitable reaction will going to take place. And because of this suitable reaction, we are getting the, what I mean to say, because of this reaction only, we are getting that particular, charging and discharging, because of the electron will flow, and ultimately we can able to charge and discharge ourselves. Right, so these are the four type of chemistry, and we will going to specifically focus on these two cells, okay, as far as chemistry is been concerned. Right. So any doubt up to this? Anyone have? Can you let me know? Any doubt up to this? Anyone have? Anyone have any doubt up to this? As far as the chemistry is been concerned, you can do let me know in the chat box. Or if it is clear, then please give a thumbs up. Any doubt, anyone else? Okay, fine. So let us move quickly to next thing, which is nothing but the parameters of that cell. Then we'll any doubt. Bansi Patel, you can do let me know if you have any doubt. You can unmute yourself, no issues. You had raised your hand. Yeah, I'm not able to hear you, Bansi. If it's possible, then please can unmute yourself. Okay, fine. I hope by mistakenly he had raised his hand. Okay. So let us move to something called as the battery parameters. Battery parameters are nothing but those set of parameters based on which we are claiming that lithium-ion battery is good for that particular usable and lithium-ion battery is not good for that particular usable. Right. So if I'm talking about a cell voltage, right? So cell voltage is the one parameters, right? You can see cell voltage is nothing but what is being happening, guys, in cell actually. We have two electrodes generally. One like this and one like this, right? So what will be happen in that two electrode? What will be happen in the two electrode? What do we understand as the voltage? Voltage is nothing but it's been created because of the potential difference between 2 points. So voltage is that amount of energy which a particular charge required in order to move from one point to the another point, right? So what will be happen? The push, right? So what will be happen whenever the ions is being moving? That movement of the ions will create some deficiencies of electron at one side and increase of electron at one side. So that led to the creation of voltage, and because of that voltage, the particular electrons start moving from one side to the another side. So one side will be act as an oxidation is being happening at one place, and another side there is something called as reduction is happening on another place, right? So if we wanted to calculate the E of cell, how do we calculate the E of cell? We will calculate the E of oxidations. Okay, we will going to calculate the E of reduction minus E of oxidations. We'll calculate the voltage of the cell by this particular formula. And if we'll go and calculate it for, having a particular equation, so we have something called as Nernst equation. So this is the electrochemical equation which is being developed, and that is called as Nernst equation, right? Where E is nothing but called as electrochemical potential. E is nothing but called as the EMF of the cell, and it is called as the electrode potential of the cell, and E naught is nothing but called as the standard electrode potential of the cell, SEP, right? Electrode potential of the cell is nothing but at normal condition. What is the electrode potential? This particular cell is, for example, this has some you wanted to calculate a electrode potential of a cell. How do we calculate? We'll calculate the E of reduction, we'll negative with the E of oxidation, then we'll calculate this E of cell. Then let us suppose we want to calculate E naught of cell. It is called as the standard electrode potential. How do we calculate the standard electrode potential? Standard electrode potential is being calculated at certain standard condition. We will do the same thing. We'll do the reduction. We'll minus it from the oxidation. We'll do the same thing, but we'll do at a standard condition. What is that standard condition? 1 atmospheric pressure. What is that standard condition? At room temperature. Room temperature is 25 degrees Celsius. And we will take a concentration of an electrolyte, which is 1 molar. At certain standard condition, at this standard condition, if we try to find the electrode potential across anode and cathode, so definitely the electrode potential across anode and cathode will be different. So this E naught is nothing but that standard electrode potential. If I'm talking about this E naught, is nothing but that standard electrode potential minus RT/NF ln Q. Q is the reaction coefficient. It is nothing but called as reaction coefficient. Right? So utilizing all this thing, we can able to generate what amount of voltage that particular cell is being created, right? So this thing is called as the cell voltage, and using that, every cell has some different chemistries being utilized. That's why every cell is giving you the different voltage level over it. Then we have 4 terminologies, which is specific energy, energy density, and power density. So if I'm talking about specific energy, energy density, and power density, so specific energy, it is the amount of energy that particular battery can store with respect to its per unit mass. That is nothing but what is the specific energy, right? If a specific energy of a particular cell is being high, so that cell in 1 kg of mass can able to store higher amount of energy, right? And if it is, for example, we have a particular cell which is called as the A. A is having 250 watt hour per kg, right? And B is having 300 watt hour per kg, right? So in 1 kg, the A is storing 250 watt hour, and in 1 kg, the B is storing 300 watt hour. That means B is storing 50 watt hour extra or 50 watt hour excess compared to A. That's why if we use this particular battery, this will going to impose lesser weight onto the vehicle, and that is the reason why we'll go for a higher specific energy things, right? It will come when we'll go for further things, right? So if I'm talking about an energy density will be more focused on the volumetric efficiency of a vehicle or volumetric efficiency of a particular cell. So it is nothing but the energy the cell is actually being stored with respect to its volume. Energy which the cell is actually being stored with respect to its volume, that is nothing but called as the energy density, right? For example, if a particular cell is having a 250 watt hour per liter and another cell is again having a 300 watt hour per liter of the energy capacity of the energy density, what will be happen? At 1 liter of space, it will going to store 250 watt hour, and at 1 liter of space, it will going to store 300 watt hour. That means at this will take the lesser space. This will take the lesser space. Why? Because in 1 liter, it will store 50 watt hour excess energy compared to the previous one. And that is the reason if you're utilizing the battery B, it will going to take lesser space, but it can give you the excess of energy as well. So any doubt? I hope someone has unmuted himself.
Yeah. Back what's the question?
Hello. Fine. So here you can see in this graph that two things which is being more there. You can see the lithium ion cells. You can see this is the lithium ion cells, and lithium ion cells will going to share a higher energy density and higher specific energy. Okay, and specific energy is called to be as the gravimetric constraint of the particular vehicle, and the volumetric constraint of a particular vehicle is called to be as the volumetric energy density. So lithium ion battery will have higher energy density and higher specific energy density. That's why in lithium ion battery, if you will manufacture a 48 volt battery pack using a lead acid battery, right, and using a lithium ion battery, you will see lithium ion battery will take lesser space and lesser volume to create that 48 volt battery. And if you use a lead acid battery will create a huge amount of battery pack, right? Even one battery, means if I can talk to you about one 12 volt, means the lithium ion battery will as smaller as one 12 volt lead acid battery pack, right? So it is very smaller. But when we are going to use one lead acid battery pack 12 volt, then we have to connect 4 in series, and ultimately we can get a 48 volt, right? So that is a huge battery pack, and again the weight of that battery pack will be very, very higher. And the lithium ion weight will be very, very low that you can able to carry it by your hand, because you have to use only 4 cells. You have to use only 4 to 5 cells, then you can able to get the 12 volt or the 48 volt like that. Right. So this is nothing but the energy density. And if I'm talking about the power density of that particular cell, power density means with respect to its volume, how much power that particular battery pack can able to deliver. That is nothing but called as the power density of a cell. That will be requiring where we require a quick power applications, and lithium ion battery is having a higher power density, and that is why they are being used inside an EV. Because whenever we'll press the accelerator, we want the sudden power should be came from a particular battery to the controller and to the motor. That's why in heavy electric vehicles, not in heavy electric vehicles, portable electronics, grid storage system, the lithium ion battery is used because they can able to deliver power relative to its volume. That the unit of that is watt per liter. Then we have something called a C rate, right? We'll have an application of the C rate while choosing the parameters, right? So what will be happen in the C rate? So C rate is nothing but called as the maximum discharge rate. What is being happening? It is not only the maximum discharge rate, it is also the maximum charge rate. For example, C rate is nothing but it is a rate at which we are charging or we are discharging the complete battery pack or even a complete cell. right? So it is a rate at which we are charging the cell, or it is a rate at which we are discharging the cell. For example, if I'm claiming I'm charging the cell at 5C, I'm charging the cell at 5C. How to read that 5C? I'm charging the cell 5 times of its capacity. 5 times of its capacity. What is the capacity of that cell? Let us suppose if I have a 100 ampere hour battery pack. So 100 ampere hour is nothing but called as the capacity of that battery pack. 100 ampere hour is nothing but called as capacity of that battery pack. If we multiply 5 into capacity, which is 10 ampere hour, then ultimately I get something called as 50 ampere. Now you have a question. Here it is ampere hour, and here we are getting ampere. How it is being possible? Because time is equal to 1 upon C rate, right? 1 upon C rate. So time is there in hours, and C rate is normally. So if I'm calculating the C rate, what is the unit of a C rate? Then C rate is nothing but 1 divided by time, which is there in hour. So 1 by hour is the unit of the C rate, right? So 10 ampere hour, and it is the unit of the C rate is, if it is ampere hour and unit of the C rate is hour, so hour got cancelled, we will remain with 50 ampere. So what is the meaning if I'm charging my battery with a rate of 5C? What that meaning? I'm charging my battery at what amount of current, which is 50 ampere. And for how much time I'm going to charge? 1 divided by 5, it is nothing but 0.2. So 0.2 hours means I have to charge it for, means if I multiply 0.2, if I multiply 0.2 multiply by 60, you can just multiply it over here. 60, so 5 for the 5 to the 10. That means if I charge it for nearly around 12 minutes, right? So I can able to charge, if one means if I can able to charge my battery pack for 12 minutes with a constant current of 50 ampere, I can able to charge my complete battery pack, that is 100 ampere hours if I'm talking. Right, so that is what is nothing but a C rate, and determining C rate is very, very important, because whenever you see the manufacturer specification sheet, they will rarely mention about the ampere. They will be mentioning about the C rate. What they will be mentioning about? They will be mentioning about C rate. That means they will be mentioned about charging C rate. They will be mentioned about discharging C rate. What is charging C rate? Charging C rate is nothing but 5C. Discharging C rate is nothing but 3C. Now the question comes, how they are being determined? They are being determined by the specific time of chemistry, right? If you have heard about the electrochemical model of a cell, if you have heard about the equivalent circuit model of a cell, right? So in the electrochemical model of a cell, they are actually charging and discharging. Calculating this charging C rate and discharging C rate will also take a huge amount of time for a manufacturer to be determined. What is happening? They are charging and discharging the cell at different C rate, and they are testing that what kind of composition change is being happening inside their battery. And if you are charging, means multiple times they are charging and discharging the particular cell at a 5C rate and 3C rate, and they are testing at what particular time the particular what particular time at what particular limit the battery capacity keeps on fading. And once they will find the capacity started fading at this particular time in the smaller intervals, then they will take the average of it, and they are saying that you can charge at 5C or you can discharge at 3C. Right? So this thing is being up to the manufacturer specification sheet. Even I can see that those who are the manufacturers of the cell, in order to describe this C rate, they are taking a huge amount of time. Even the rigorous testing of 10 days to 15 days is needed, because one test will keep you on for 1 day. Even today, if you're going to do the test inside a battery pack for a C rate of even 1C, that will take a huge amount of time, even for 1 hour and 2 hours as well. Why? Because charging and discharging the cell will take certain time. And if you wanted to determine something, right, you heard about something called as OCV versus SOC curve. You have something heard about this OCV versus SOC curve. Even to determine this OCV versus SOC curve, then only we can able to code the BMS, because based on that, whatever the curve has been coming, we can able to algorithm our BMS on the basis of that. You can take nearly around 1 month for process a particular cell OCV and SOC characteristics. It is a very, very tedious process. If you want at 92% what amount of voltage I have been, at 92.2% what amount of voltage my particular cell have been. So they require a very, very tedious process of what I meant to say, tedious process of multiple months. Even I had personally saw that in the cell manufacturing companies, 3 to 4 months they used to take in order to determine the OCV versus SOC characteristics. That is why we require some fast model which can predict the things. And that is why we had been nowadays opt for some advanced model, which we are calling as a machine learning model, right? So machine learning model is being famous for the state estimations because based on the characteristics, based on the cell's behavior, they can predict what might be happen in the future. They have multiple models in it. So based on the different characteristics of the cell, they can able to determine or they can able to tell what must be the future predictions of that particular cell, and more or less that particular thing is right. And when it comes to the cell designing a BMS, we need the accurate data. If there will be small inference of data will be happen, that will create a huge amount of deviation as far as cell safety is been concerned. That's why it is very, very required for us that because if let us suppose manufacturer somehow instead of 5C, it has written something around 6C. And if you try to charge your cell at 6C based on the BMS algorithm, and suddenly your battery catches fire, then you will get a huge state. So that is the reason why this C rate of charging and discharging has been determined with so much accuracy, with so much data laden things. And because based on this C rate only, the BMS need to be determined. Right, so that is all about the C rate. This is a LiPo battery. You can see the C rate is being written, which is 120C, and it is nothing but a 1500 mAh, right? And if you can convert mAh into AH, it is nothing but 1.5 AH. So utilizing, if you charge and discharge this particular battery at 120 seconds, this is the highest current, right? If you can able to withdraw 120 multiplied by 1.5 times of current, then this particular thing will be discharged in certain minutes or a second, right? So C rate is very, very important as far as battery is been concerned, because the manufacturer will not going to showcase you the current rate. The manufacturer will showcase you the C rate, and based on the C rate you can charge and discharge the cell, and you can get the capacity of that particular space, right? So useful capacity is nothing but that capacity of the battery which is exactly usable by us, right? For example, if I'm talking about the OCB versus SOC characteristics of a lithium-ion cell, it is looking like this. It is looking like this, right? It is looking like this. Means it will start from here, so it will be looking like this. Means in this region, whatever the voltage is being there, you can use that. Okay, you can use from 2 volt and you can go up to nearly around 4.0 volt, right? The maximum voltage is 4.2 volt, right? You cannot go below the 2 volt and you cannot go beyond the 4 volt, because to protect any kind of overcharging inside the cell, right? So useful capacity is exactly saying what amount of value, means what amount of area you can use, right? And for example, if the battery is 6 ampere hour, then useful capacity is the 90%. Right? Because whenever you will put the algorithm, you will command the battery management system that this is the useful capacity, right? It is not like that the 90% of, if you're going to, let us suppose if you're going to calculate the 90% of 6 ampere hour, it is comes to be nearly around 5.7 ampere hour. That means you will have to lose 0.3 ampere hour. So it is not like that you will lose the 0.3 ampere hour from 6 ampere hour. From initial, you have to lose some 0.15 ampere hour, and from here you have to lose some 0.15 ampere hour. And then only you can able to lose the complete ampere hour things, right? So useful capacity is that usable capacity which can be practically used by the battery pack. Below that and beyond that, we cannot use anything, right? If it is fall below something, then we cannot use. If it is go beyond something, we cannot use, because that will be not safe for the battery pack is been concerned. If we will fall below, then we will be move into the deep discharge mode. If we will be fall up, then we will be go into the overcharge mode. And that is the reason why you can see lithium-ion battery is being used. Means there are multiple industries you can use for the medical applications. You will rarely see that lithium-ion battery is being utilized in the medical applications. Why? Because lithium-ion battery have a lot of constraint of deep discharge, overcharge. So utilizing them inside that particular thing will be huge stake. And that is the reason why the lithium-ion battery has been not utilized for the medical appliances and the applications has been concerned. Majority. In the medical appliances or application, majority time you will going to see the metal hydride batteries still utilizing the metal hydride battery, because metal hydride battery don't have this flat characteristics, one, and second, the metal hydride battery is more predictable compared to the lithium-ion batteries, right? So this is the table which can showcase us that why lithium-ion battery is surpassing all other battery chemistries. because the cell voltage of individual lithium ion is compared to other was very high. Specific energy density and power density of a lithium ion battery compared to other chemistry again is very high. If I'm talking about a maximum discharge, then your lithium ion battery will give you a wide range of C rate, which is not being given by the lead acid battery, nickel cadmium and nickel metal hydride battery, because nickel cadmium and nickel metal hydride battery have something called as disadvantages of memory effect and disadvantages of memory effect and self discharge. That is the reason we cannot opt them for a higher amount of C rate. But when I'm compared to lead acid battery, again we cannot opt them for a higher amount of C rate, because if we try to charge or fast charge the lead acid battery, it will going to form a oxygen. It will going to form a huge amount of hydrogen gases, and it will heat up the complete battery pack as well. It will swell the complete lead acid battery. Right. So even you cannot see the lead acid battery is fast charge maximum time. Generally, the float charging is used in the lead acid battery. Okay, fast charging in the lead acid battery or boost charging in the lead acid battery is being required in the industrial process, where the lead sulfate is properly offered onto the electrode plate, and the lead sulfate, to remove the lead sulfate, we have to use the boost charging capacity. And if I'm talking about useful capacity, it will be more in lithium-ion battery compared to all other battery chemistry. Charging efficiency of the lithium-ion battery is very high. Self-discharge of lithium-ion battery is almost negligible. Even in lead-acid battery also self-discharge is almost negligible. But NiCd and NiMH battery shall have some self-discharge rate. Temperature range of lithium-ion battery is very high. Cycle life of the lithium-ion battery is even high, and that is why you are getting good cycle life in the lithium-ion battery. Memory effect in the lithium-ion battery is not there, and the microcycle tolerance, very impactful, very important. The microcycle tolerance of the lithium-ion battery will go, right? But lithium-ion battery alone cannot be usable. The robustness is not comes in the lithium-ion battery if we use it without BMS. BMS is very important as far as lithium-ion battery is concerned, because without BMS, lithium-ion battery cannot able to surpass any kind of current and any kind of discurrent. Because if we will discharge and charge the lithium-ion battery pack without any help of a BMS, ultimately lithium-ion battery will catch fire with no instance. That is the reason why, because lithium-ion battery will have a huge energy inside it. In a smaller size, it can able to store huge amount of energy. And if smaller fluctuation will be happening, it will lead to a disastrous thing. And that is the reason you will see majority of the blast will be happen in the lithium-ion battery itself, right? Rarely you can see about lead acid battery, because lead cannot store that much amount of energy what lithium can store. Right, so I hope that thing is been cleared, or have any doubt from the battery chemistry, just quickly do let me know. Then we'll go for a chemistry of a lead acid, and we'll go for a chemistry of a lithium-ion battery. Then we'll offer a testing process of. Any doubt anyone have? Yeah, Bansi, you have any doubt? Yeah, Anshuman.
So can you please explain about the calculation of C rating? And I have a doubt regarding that.
Okay, you wanted a calculation of a C rating?
Yes, sir.
Let me explain you with the example of this, right? So let us suppose you have, my screen is visible, right? Is my screen? So let us suppose you have a C rate of 120 C. Let us suppose this is the C rate. 120 C, right? And if I'll ask you, you have a capacity is being represented by Q, and we have a capacity of 1500 mAh, and we have to convert them into the ampere hour. So we'll divide them by 1000. So what we'll get? 1.5 Ah. Right? We are saying that our mobile phones have 500 mAh, 5000 mAh, 6000 mAh, 8000 mAh. So this is nothing but mAh, milliampere hour. If we'll convert them into the ampere hour, we'll divide by the 1000 and we'll get to the 1.5 ampere hour. Now, if I'll ask you, we can, the C rating of that particular battery is this. I'm not talking about we can charge it or we can discharge. I'm talking we can charge it also at 120 C rate. We can also discharge it also at 120 C rate. Let us suppose what do it means if we're going to charge it with 120 C rate and if we're going to discharge it with 120 C rate. What it means? Means if I wanted to test the means 120, if you wanted to charge it at 120 C rate, how do we charge? 120 times of capacity. What do we understand by that? 120 times of capacity. What is the 120 times of capacity? 120 multiplied by 1.5. If you do this calculation, what will become? 1.5 into 120. That is nothing but 180 ampere. Means if you wanted to charge and discharge that particular cell, this is the maximum current which we can provide. And let us suppose if somehow we can able to provide it while discharging, we cannot go beyond this particular current. But let us suppose while charging, if the charger is pumped somehow 200 ampere of current to this particular cell, so this particular cell will going to be gone. Because this is the maximum current. This is 180 ampere is the maximum current in which we can able to charge or in which we can able to discharge. Beyond this current, we cannot able to move. Beyond this current, we cannot able to move. Now the question comes, let us suppose we are absorbing 180 ampere from it. We are absorbing 180 ampere from it. Let us suppose we are absorbing 180 ampere from it. Let us suppose if I'm talking that constantly I'm absorbing 180 ampere from the complete battery pack. Constantly I'm absorbing 180 ampere from the complete battery pack, means constantly I'm discharging 180 ampere from the complete battery pack. So how much time this battery pack will sustain? How much time the battery pack will going to sustain after, means 30 minutes, 40 minutes, 15 seconds, 16 seconds, means if I'm constantly extracting 180 ampere from the complete battery pack, so how much time this particular battery pack will going to sustain? That time. Hello?
ನೀನೇ ನೋಡ್ತಾ ಬಿಟ್ಟ.
Converted himself.
ನಾನು ನೋಡ್ದೆ ಸರ್ ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ.
Please, can you mute your mic, please? So let us suppose I'm constantly getting 180 ampere from the battery pack. So how much time my battery pack will going to sustain? That time will be determined by the formula, which is nothing but time in hours. If you wanted to determine, it will come from something called as 1 divided by C rate. What is that C rate? 1 divided by 120, right? So if we divide 1 divided by 120, we'll get something around 0.008 hours, right? So what is 0.008 hours? Let me multiply by 60. We can convert it to minute. Again, let me convert it to second. That is nothing but 29.9 seconds, which is nearly equal to 30 seconds. Means if you are constantly extracting 180 ampere for 30 seconds from this complete battery pack, your battery pack will be completely discharged. Your battery pack will be completely discharged. That is the meaning of that C rate. Right now the question comes, now you will ask, sir, from where this time is equal to 1 by C rate comes? Actually, you can see this formula. What is the discharge time? Discharge time has been calculated by this formula. Discharge time has been calculated by this formula. This formula. Discharge time is equal to battery capacity. Battery capacity, which has been given in which term? Ampere hour, divided by charging or discharging current, right? Which has been given in ampere. Which has been given in ampere. Now the question comes, how do we find the charging and discharging current? There is again a formula for charging and discharging current. Charge oblique discharge current can be calculated as capacity, which has been given in ampere hour, multiplied by C rate, right? So if you put this thing over here, what will be happen? Battery capacity in ampere hour. I'm just like the abbreviations of it, divided by, if you wanted to write charge and discharge current, how will I write? I will write battery capacity multiplied by C rate. So here the battery capacity will be cancelled. So what will be the discharging time, which is in hour? It is 1 divided by C rate. This is the a smaller derivation of it. So what do we understand by the C rate? That if we are going to discharge the particular battery pack for continuously, we are going to extract 180 ampere for 30 seconds, then we are going to completely discharge the battery, right? Getting, this is the implications of that C rate, because C rate will tell how fast you can able to charge your battery, how fast you can able to discharge your battery. Right? If we can reduce the C rate, let us suppose if I can reduce the C rate to 60. So what will be happen? Just calculate it. 60 multiplied by 1.5. You will get something around 90 ampere. Means you will constantly extract 90 ampere from the battery pack. So what will be happen? If you are going to extract 180 ampere, so it will be sustained for 30 seconds. If you're going to continuously extract 90 ampere, so how much time you will going to extract? 1 hour, because 90 plus 90 is 180, right? Just solve it by this thing, 1 divided by C rate. What is C rate? Let us suppose 60, right? So 1 divided by 60 is nothing but called as 0.16. Multiply by 60, multiply by 60, you will get something around 59.9 minutes, which is nothing but called as 1 hour. Right? I'm doing nothing. I'm just coming with something called as I'm coming something called as, if I'll divide 1 by 60, I'll get something around 0.016 hour. Right? So I need to convert this hour in, because I don't know what is 0.016 hour. So I need to convert them into the specific minute or a second. Right? So if I'll convert them into, if I'll convert them, it is second, it is not minute. If I'll convert them into second, what I'll have to do? If I'll convert them into the minute, what I'll have to do? I have to multiply by 60. Then again, something will become, then again, if I'll multiply it by 60, then I can convert it to the second. Right? So how many seconds it will take? 60 seconds. That means 1 minute. I'm sorry, here I'm by mistakenly written 1 hour, but it is 1 minute. Right? So whenever you are going to charge and discharge the cell, by setting up the parameter, you are requiring this value. Right? Just now, after the completion of this chemistry, I will showcase you in the system. You are actually requiring this value, 180 ampere, right? Because you don't requiring this type, you are requiring 180 ampere. Then if you plot the thing in parameter, the thing in system, based on that, it will going to charge and discharge the cell, and based on that, it will showcase you the curve. And using that curve, you can do, or you can analyze n number of things. Getting? Is this
Yes,
thing
sir.
yeah. Any further doubts?
No, sir, I was only confused in that part about the C rating, like how many like how much time it takes the battery to discharge if there is like 0.5 C or 1 C or 10 C. Now I got it.
Yeah. Great. Okay. So
Thank
I
you.
hope, yeah, welcome. I hope we shall move forward to the battery chemistry, which is more important, right? So let us go for a very first cell, which is being, I told you about when the Alejandro Volta had developed the cell. That cell is called as the Daniell cell, right? So whenever I'm talking about the Daniell cell, the operation of a Daniell cell is very, very simple. What is been happening? Let us suppose in the Daniell cell, this is the Daniell cell. What is been happening over here? The zinc is being dipped inside an electrolyte, which is called as zinc sulfate solution, right? And this copper is being dissolved in a solution, which is called as copper sulfate solution, CuSO4, right? So zinc sulfate is being dissolved inside of water, and water is a polar solvent. And whenever you will dissolve any component inside a polar solvent, always they will lead to the creation of zinc 2 plus and SO4 2 minus. So instead of zinc sulfate, they have something called as zinc 2 plus ion and SO4 2 minus, right? So what will be happen? First of all, what will be happen? This NaSO4 are being there. So what will be happen here? Let us suppose instead of NaSO4, this is a bit difficult to make you understand. What I will do, I will take it A plus Cl minus, let's suppose. Cl minus K plus, right? So this salt bridge is acting as what I meant to say. If you're not going to use this salt bridge, then your circuit will not going to be complete. Then you will not going to flow the current, right? Your bulb will not flow. So that is the reason why you have to use that salt bridge. What will be happen? You will use the Cl minus ion. So what this Cl minus ion will do? Cl minus ion will be come into this particular electrolyte. It will form the bond with Zn and lead to the creation of ZnCl2. Right. In this way, the concentration of zinc 2 plus inside the electrode will going to be reduced. The concentration of zinc 2 plus inside the electrode will going to be reduced. Then the electrode, which is being there, they will release 2 electrons. The zinc will suddenly release 2 electrons and they will be jump into this electrolyte. And this 2 electron will be travel through the external circuit and they will be reach over here. The 2 electron will be reach over here. Once the 2 electron will be reach over here, so here also we have copper 2 plus and SO4 2 minus ions is being there. So this copper 2 plus will go and capture this 2 electron and try to deposit on the copper plate. The copper 2 plus ions will try to deposit on this copper plate by capturing 2 electrons, right? And this K plus will come into this electrolyte and form a bond with SO4 2 minus, because SO4 2 minus cannot able to stay alone in the electrolyte. That's why it need to form a bond and led to the creation of K2SO4. Right? And you can see the constituent of a K2SO4 is being remain over here. So you can see here the electron are being coming here, the electron are flowing out. Means this particular electrode is losing the electron. That means here oxidation is taking place. And if oxidation is taking place over here, that is called as anode. And here, if you can able to see what is being happening here, the electron is gaining. If the electron is gaining, then what will be happen here? The reduction is actually taking place. Here, what is happening? The reduction is taking place, right? And if the reduction is taking place, what we can call them as a cathode. And slowly, you will find one thing. When all the zinc will be come and dipped inside the electrolyte, slowly, this particular thing will going to be shredded out. And once the zinc will completely decomposed, then you will find the complete cell is being discharged. But if we connect a charger, this zinc cannot get recreated. Every primary cell you will see, this zinc is acting as a negative electrode only. You can go and take any, alkaline cell which you are putting inside AA and AAA cell. They are consisting of this zinc only, right? And zinc has a nature, they can easily decompose, but they cannot get recreated. And that is the reason all the primary cells are, is something which is never getting recreated. That's why once we will completely use, we have to throw them out. There is no other options left, right? So you can see this is one kind of dry cell, right? Just we'll go to the this is a dry cell which we are calling it as a Leclanche cell. This cell is being invented by the scientist called as Leclanche in the year 1966. This cell is being invented by Leclanche in the year 1966. We'll understand the working principle of this Leclanche cell, which is very, very easy. What is been happening here? You have something called as the outer surface of the Leclanche cell. We have something called as the outer surface of the Leclanche cell, which is nothing but made up of what? Which is nothing but made up of the zinc case. Right? You can see here the zinc is being there. Then it will go inside it. You will see the white color paste, and this white color paste is nothing but called as ammonium chloride. Ammonium chloride means NH3Cl. Sorry, NH4Cl. Ammonium chloride is nothing but called as NH4Cl. What is this? NH4Cl. Then if you go inside, you will find a manganese 4 oxide. Then if you go inside, you will find what? You will find a manganese 4 oxide. That means MnO2. Right? It is being there. Right? It is called a manganese 4 oxide. Right? Then if you go inside, you will find a carbon rod. This is nothing but that carbon rod. Right? What will be happen? Whenever you're going to connect anything to this particular, you will going to connect a cell like this, battery like this, a bulb like this. What will be happen? The zinc will release 2 electron and become zinc 2 plus and jump into the electrolyte. So when the zinc will jump into the electrolyte, what the zinc will do? Zinc will displace this ammonia and lead to the and get the formation of bond with zinc chloride and lead to the creation of zinc chloride. ZnCl. And we have what left? We have NH4 is being left. How the structure of NH4 is being become? NH4 is just like H50 bond H3N. This is nothing but the structure of NH4. Right? If it means there is 2 molecules of NH4 is actually been left. Just give me a moment. Right? 2 molecules of this thing is being left. So what will be happen when this NH4Cl, when this NH4 remains, and this is what the structure of NH4 is being looking like. Right? When this NH3 is being there, they will be remain, they will be hovering around, and in search of electron, what they will do? They will be moved towards this manganese oxide and they will be reach over here. When the electron, when they will reach over here, right, they will absorb 1 electron. Once they will be absorb 1 electron, what will be happen? They will absorb 2 electron. So this H will get 1 electron, another H will get another electron, and once the reaction will be taking place, they led to the creation of NH3 plus they led to the reaction of H2. Means hydrogen and NH3 is actually been absorbed. Hydrogen and NH3 will actually been created. And this NH3 and hydrogen is nothing but called as the gas. Right? So we just inside a closed compact cell, the creation of gas is being happening. What is that gas? This is ammonium gas. This is ammonium gas. Sorry, this is ammonia gas. Sorry. It is ammonium is NH4. This is ammonia gas and this is hydrogen gas. right? This is hydrogen gas. So we need to suppress the gas, else this gas will going to explode the complete battery, right? So suppression of NS3 is being done by something called as ZnCl2, right? So NS3 will be react with ZnCl2, NS3 will be react with ZnCl2, and then led to the creation of ZnNH3 Cl2, which is nothing but called as zinc complex. Which is nothing but called as zinc complex. And this complex will be there in the solid form. This complex is being there in the solid form. So whatever the gas we had created because of ammonia, with the reaction with ZnCl2, we had been converted them into the solid format. Then we have only one gas left. Now this gas is being suppressed by whom? That is the reason why we had used this manganese ore oxide. So this manganese oxide will be react with H2, right? And it led to the creation of water and Mn2O3. It led to the creation of water and Mn2O3. And this Mn2O3 is nothing but in the presence of water. What will be happening is, this is the cell which actually I had opened from here, right? This is the cell which I had practically opened. I don't have that cell currently with me. Once you're going to open this cell, the manganese oxide, you will, while the manufacturing, this is there in the powder format. While manufacturing, this manganese oxide will be there in the powder format. Means here you will be add the manganese oxide in the powder format. Once you open the cell after discharging, what will happen? This is not in the powder format. This will be in a paste format. When you will touch this particular cell, you will find this particular cell will be in the paste format. Why? Because of the presence of water. Because Mn2O3 will be dipped with the water, and that's why if initially you had entered this initially if you had entered this manganese ore oxide, you will be inserted them inside the particular cell in the powder format. But once this cell is completely discharged, then we'll cut this cell, and if we try to touch around this carbon rod, we'll find a moist paste. So how the moist paste has been created? That is the reason of water, right? And here the H2 is being suppressed into the water. Okay, but this cell is highly self-discharged cell. Why this is highly self-discharged cell? Because you have a question, sir. Here Zn will come and this. Just give me a moment, guys. I'm getting bit, issue in writing. Let me zoom it light. Yeah. So let us suppose if here what will be happen? The zinc will come and it will going to displace the NH4 and lead to the creation of zinc chloride, and it will remain. What will remain? This NH3 will remain. This NH3 will remain. Means inside this electrolyte, the NH3 will remain. Right? Now the NH3 will take all the back to here and it will absorb the electron. Why this thing will be happen? Because electron is being released over here itself. So NH3, instead of going into the inner periphery, they will absorb the electron here itself. Even though you don't able to connect any kind of load, the NH3 keep on absorbing the electron here, and that is the reason why this Leclanche cell is highly discharged cell. Right? That is why you have to give some lamination in between. And that is where the multiple companies comes into action, and they invented some lamination because that is the propriety of them. They don't reveal. Right? So that's why you cannot find in any article, you cannot find in any research paper that anyone mentioned about the proper composition of this lamination, because this lamination will make their battery less, because Duracell will claim that my battery will be long lasting for 5 years. It will not even use for 1 year. My Leclanches will be long lasting for 1 year. And then in terms, Exide will come. Exide will say my battery will be lasted for 2 years. Because Exide will use some lamination, which will be stop this particular internal reaction for a higher time. But if I'm talking about in that case, if there is something called as Duracell have used some low quality lamination, because of which their battery, this internal reaction will be stopped for certain region or for certain time. Right? So based on this laminations only, they can claim that my battery will be sustained for 2 years if you have never used. And based on this lamination only, one can claim my battery will be sustained for only 1 year. Right? So this is a small things, guys. If you wanted to start a startup, you don't have to think a very bigger thing. Right? The small thing even you can go and you can opt for any kind of startups. Right? Just by making a sensors, people can earn a lakhs of rupees, right? Because all the sensors, even the Hall effect sensors which we are utilizing inside a motor, that is not even manufactured in India. We are outsourced, right? So they're charging us a huge, right? So that is the reason why government is opting for Atmanirbhar Bharat. That is the reason for it, right? Because they wanted to be procuring and manufacturing of everything inside the India itself, so that the cost of the EV will going to reduce. And this budget is very friendly as far as manufacturing in India is been concerned. Even extracting of rare earth element from the India is been concerned. Very, very important that this budget is being. So we'll not going for this alkaline battery, guys, because this alkaline battery is just the replacement of Lagrange cell. So here, instead of utilizing NH4Cl, we had just changed the electrolyte, and we had changed the electrolyte into QOH. That's why currently we are actually using in our home whatever the primary cell, that is this cell only, right? So it is the carbon collector. So we're not going for that. Instead of that, we'll go for the working principle of the lead acid battery, right? So if I'm talking about the lead acid battery, so any doubt from the primary cells up to here? Anyone have any doubt from this Lagrange cells or alkaline cells? The reactions will remain the same, guys. Just we had changed the electrolyte. While changing the electrolyte, because this particular thing have a zinc, if zinc will lose electron will be come over here and it will be good. And here we have something called as the positive electrode, and in the middle you will see the separator, right? So as we change the design, as we change the electrolyte concentration, then everything will remain changed, right? So is this thing clear, guys, or have any doubt with the chemistry? Or else we will go for a lead acid battery chemistry, then we have lithium ion. Any doubts? Any doubts anyone have? In the presentation. Okay, someone have written something in the chat box. Is it really better? I can go up to that questions at the end of the session. So let me keep forward because we have other things as well. So we'll entertain this questions at the end of the session, right? So if I'm talking about a lead acid battery, right? So you can see in the primary cells what is happening. The zinc has been completely consumed, but the zinc has been completely decomposed. But in a lead acid battery, you cannot see any kind of decomposition reaction. In the lead acid battery, you will see the conversion reaction because lead has been converted to some other component, and while charging, lead will be reconverted back into the same form, right? So here, if I'm talking about the positive electrode is made up of lead dioxide. Negative electrode is made up of the sponge lead, right? And the separator is, I told you that it is every battery, irrespective of every battery, separator remain constant. It is made up of polyethylene and polypropylene material. And electrolyte, if I'm talking about inside a battery, that is made up of the combination of sulfuric acid and the water, right? So you can see over here, right? Once you're going to charge the battery, once you're going to discharge the battery, and here if I'm talking about the sulfuric acid and the concentration of the water, they'll be there in 1:3 concentration. Means if you will take a 1 liter of sulfuric acid, then you have to take a 3 liters of water, right? So this is nothing but called as dilute sulfuric acid. That instead in certain book it was written dilute sulfuric acid is being used. So if I'm talking about discharging, the discharging phenomenon, what will be happen? We have H2SO4, right? So H and SO4 is getting separated, right? Because I told you H2SO4 is being there in the water, as water is the polar solvent. So what will be happen? H2SO4 is being segregated into H plus and SO4 minus ion, right? During the discharging, what will be happen? What will be happen? Here you will find a lead. What will be happen in the lead? The SO4 minus will attracted towards this lead. They will lead to the creation of a lead sulfate. Means they will release 2 electron, and that 2 electron will be flow through this negative electrode, and they'll be reach over this particular positive electrode over here, right? And this sulfate ions will be getting a form with this Pb, and they led to the creation of a lead sulfate, right? So this lead sulfate will be go over here, and they'll be reached. This lead sulfate is nothing but there in the crystal format. I'm talking about a lead sulfate. It is been there in the crystal format. If I can talking about this lead sulfate, it is there in the crystal format. Crystal format means they led to the creation of a crystal inside this particular lead electrode. And in the negative, in the positive electrode, if I'm talking about the lead dioxide is being already there, then we have something called as H plus ions, right? This H plus ions will absorb electron and lead to the creation of an H2, right? And this H2 will going to snatch one oxygen from this PBU and led to the creation of PBO. And this PBO will react with SO4 and led to the creation of PbSO4 and release some amount of water into it. Right? And that is the reason in both the sides you will lead to the creation of a lead sulfate crystal. Right? What will be happen when the concentration of a lead sulfate crystal is increasing inside an electrode? The electron holding capacity of the both electrode is going to reduce. And if the electron holding capacity of both electrode, if it is being reduced, then the electron cannot be held from the electrode for longer time. And that is the reason why the battery has been completely discharged. That means what had happened? Lead is been converted into lead sulfate. Lead dioxide is here is also converted into the lead sulfate. Then in the second equation, if we can talking about here, in the second equation, what will be happen? We had already have a lead sulfate here and we had already have a lead sulfate here. We have to reconvert them into the pure lead. What will be happening over here? We're going to connect negative to the negative and positive to the positive. So from the battery, you can see the charger will do nothing. The charger will create an electric field, right? So because of that electric field, what will be happen? This is the positive plate. So sulfate ions will be comes towards this positive plate. What will be happen? Let us suppose because of this positive plate, the sulfate ions will attracted towards this positive plate. When the sulfate ions will be attracted towards this positive plate, they will be react with PbSO4 and lead to the creation of a PbO2 and release 2 electron. Because sulfate ion when release 2 electron become a radical sulfate, which is SO4. And radical sulfate won't stable in this radical format. They have to react with some element. So that is why they will be react with PbSO4 and lead to the creation of lead dioxide, and they will release the H2SO4 inside the electrolyte. Right? So the electron will be released, and because of this electric field, electron will try to flow from the positive electrode and they will be reached to the negative electrode. And once the electron will be reached to the negative electrode, the hydrogen ion will come and they will snatch this electrode. And once the hydrogen will snatch this electron, they become H, and again another hydrogen will come and again it will snatch one electron and become H, and then lead to the creation of H2. And this H2 will again attack the PbSO4 and lead to the creation of H2SO4 and release one lead. Right? So again here what had happened, lead sulfate is again converted into the lead dioxide in the positive plate, and in the negative plate it has been again converted into the sponge lead. Right? So this is the reaction, this is the chemical reaction which is being happening in the lead acid battery. Nowadays, if I'm talking about a lead acid battery, this is how the lead acid battery is being looking like. You can see in the front, you have something called as grid. This is nothing but called as the grid. And you can see this is the positive plate, right? If I'm talking about a positive plate, so this positive plate is actually been pasted above this grid, right? Initially, what is being happen? The positive plate is made up of a pure solid element, but after that, what will be happen? This grid we are going to create a paste in the positive plate, and we will have to paste it above the grid. This grid is something which is being made up of a lead-based alloy, right? It is made up of the lead-based alloy, right? And some amount of additives is also being added into it, like calcium to give him strength, antimony or tin or silver to enhance its strength, conductivity, and reduce any kind of self-discharge, right? So when I'm talking about a grid is not made up of a pure lead. Instead of that, they are made up of a lead-based alloy, whether it is tin, whether it is antimony, whether it is silver, they are made up of the lead-based alloy. And above that only, we're going to have the paste, right? And similarly, the negative electrode will also paste on this grid-like structure. So this grid will act as a body above which we're going to have the paste of an electrode, and in between we'll have a separator. So this is the complete structure of a lead-acid battery. And each lead-acid battery will going to generate 2 volt and very lesser capacity. That's why in order to increase the capacity, we have to combine a lot of plate in between. So this will going to create a 2 volt, but the capacity will be very, very high. Again, this will going to create a 2 volt, but the capacity will be very, very high. If we're going to connect 6 battery in this way, so we're going to create a 12 volt and something around higher capacity, whatsoever the capacity is being there. Right? You can see the valve is being present over here. Nowadays, we are utilizing a valve regulated lead acid battery, and you can see the valve is being present over there. But the valve is being present over there, that will useful for the exemption of the gases. Means the gases will go out from that particular valve in any adverse cases, right? So nowadays, if I'm talking about, there is something called as AGM based battery. Means instead of utilizing the liquid electrolyte as we are utilizing in this case, we are utilizing something called as AGM based batteries, right? In the AGM based batteries, we're utilizing something called as glass mat. Right, and this glass mat is being dipped inside a concentration of H2SO4 and water, and they will be absorb the H2SO4 and water in the concentration of 1:3. Right, and that glass mat is being pasted in between the positive and the negative electrode, and the separator is being pasted in between. Right, so that is called as absorbent glass mat batteries. Right, so instead of utilizing a liquid electrolyte, we are utilizing a glass mat electrolyte in which the electrolyte is being absorbed rather than utilizing a proper electrolyte. So for example, if you're utilizing a flooded in case of our home inverters batteries, they are actually the flooded batteries because they will have a pure electrolyte. That's why they are requiring a topping up of water. But in AGM batteries, we don't require any top up of water because they are actually having absorbed the water inside it. In the gel-based battery, we are utilizing the gel instead of utilizing a liquid. We are utilizing the gel, and that is more safe compared to the liquid battery. But AGM batteries will be more safe. Apart from that, they will be spill proof more compared to gel and compared to the liquid one. So this is the difference between a flooded lead acid battery, gel-based battery, and AGM batteries is being there. Nowadays, we are saying that in our automotive application, we are utilizing a dry battery. Dry battery is nothing but that AGM batteries. So in an automotive starters, with the battery which we are utilizing, that is called as AGM batteries, and they are nothing but a VRLA. VRLA stands for valve regulated lead acid batteries being there. Right, so we can mount that particular battery in various combinations. Nothing will be happening because if that is a liquid, then we have a fear of spilling out. If that is not a liquid, then we don't have a fear of spilling out. Right. Okay, so let us move to the lithium-ion batteries, guys. This is one of the last, thing which we need to become out. So lithium-ion battery, again, it will going to use the negative electrode, positive electrode, and again the electrolyte and separator, right? And any electrode, if we will have active material, we will have binders, we will have conductive additives, we will have a collectors, right? Active material is something which will purely take part in the chemical reactions. Binders is something which will, because we will not going to use only active materials. We're going to use active materials, we're going to use conductive additives, we will going to use other additives, right, as well as. So let us suppose we are cooking something, we'll add active material, we'll add binders, we'll add conductive additives. So binder will act as a glue to add all those elements together. Right. So in a negative electrode, what are the active material we are utilizing? Graphite, LTO, and silicon we are utilizing in the negative electrode. And if I'm talking about the binders in the negative electrode, generally we are utilizing the binder which is called as styrene butadiene rubber. SBR is the binder which is being utilized in the negative electrode. PVDF has some environmental concerns. That's why we are not utilizing PVDF in the negative electrode. And conductive additive we are adding just for the purpose to increase the conductivity of that particular electrode, right? That is always the carbon. Everywhere in the lead acid battery also, what the conductive element we are adding, that is carbon. But along with that, we are adding 15% some extra thing in order to increase the efficiencies of the battery. That thing is again a propriety of that company who is manufacturing that particular cell, that you cannot able to know that things, right? So if I'm talking about a positive electrode of lithium-ion battery. So again, the positive electrode will have something called as active material. Again, the positive electrode will have something called as binders. Again, they have something called as conductive additives, right? So active materials in the positive electrode is nothing but LiCO2. This is called as LCO. This is called as NCA batteries. This is called as NMC batteries. This is called as LMO batteries. This is called as LFP batteries. You can see. Right. So based on what we are utilizing in the positive electrode, based on that only we are claiming it is NMC battery, it is LFP battery, it is NCO batteries, it is NCA batteries, right? And again, the binders which we are utilizing in the positive electrode is the polytetrafluoroethylene. This is PTFE we are utilizing. Why? Because again, I told you PVDF is having some environmental concern. We can use, but PVDF have some environmental concerns. That's why we don't using this, right? And again, the conductive additives we are utilizing the carbon black, but only the carbon black is not being utilized because multiple things are being there, which is again a propriety of that company. They will never choose. And current collector, we are always utilizing aluminum in the positive and copper in the negative, right? So these are the structures of that positive materials. If you're utilizing LCO, if you're utilizing LMO, if you're utilizing LFP, these are the structures of it. And if I'm talking about an electrolyte, so what are the electrolyte we are utilizing inside an inside a lithium-ion battery? That is again the combination of salt and solvent, right? So if I'm talking about which salt and which solvent we are utilizing, so we are utilizing dimethyl carbonate, which is a popular solvent candidate for the purpose of electrolyte, right? For the solvent, right? We are not only going to use the dimethyl carbonate, we're going to use the ethylene carbonate as well. So ethylene carbonate, EC plus DMC mixture we have to use in case of an electrolyte. This is act as a solvent, right? Then we will be, because this solvent will something which will help in the creation of something which we are called as SEI. If we're not going to use EC, then we cannot able to create this SEI structure. Solid electrolyte interface will not going to be came out. And in terms of electrolytic salt, 90% of the battery which is utilizing electrolytic salt, that is nothing but lithium hexafluorophosphate, right? So utilizing this salt will make something impact, right? And this is the microscopic image of a separator. You can see this is a polyethylene polypropylene material. That's why I told you they have some small pores through which the ions can easily pass, but they won't allow any contact between a positive and negative electron, right? So this is how the working of a lithium-ion battery will going to happen, that during the charging process, we are utilizing some lithium metal oxide. So that lithium metal oxide, when we're going to connect the charger, will release one lithium ion and from the metal oxide and release one electron. That electron will be in the presence of an electric field will be led towards the negative plate, right? And in the negative plate, and the lithium will be comes from the electrolyte, right? So the lithium will not going to react with this graphite structure. Instead of that, they will be go and sit inside the space of graphite, and that is nothing but called as intercalation. So here the intercalation is being happening, and again the lithium will gain one electron and led to the creation of lithiated carbon, right? During the discharging process, what will be happen when we will connect the bulb across the battery pack? The metal oxide means the lithiated carbon. Again, the lithium will be separate itself from the carbon or from the graphite structure, and the graphite remain as it is. Lithium will release one electron, and that electron will travel from the node and led to the current will be flow, and the electron will be reach over here, and it will react with metal oxide and lithium. In the presence of electron, they led to the creation of lithium metal oxide, right? So lithium will be flow from here and there. The to flow movement of lithium from the internal of the electrolyte and the to flow movement of the electron from the external circuit will lead to the creation of a battery to be prepared, right? So that is all about the lithium-ion batteries, guys. If we go for a manufacturing part of a lithium-ion batteries, so these are the various manufacturing process of a particular lithium-ion battery, because we need to connect the cells in series and parallel. Once we're going to connect the cells in series and parallel, then only we can able to make a complete battery pack, right? So you can see there is a process which is called as the grading. There is a process which is called as the sorting. This grading is a technique where from the 1000 cell, we are testing the capacity of a specific cell, right? Okay, so we are checking the capacity at CCCV profile. So at CCCV charge and discharge, we are checking the capacity of that particular cell. For example, we have 1000 cells. Then from that 1000 cell, we have to select 12 cells. So we're going to test that 1000 cell in a grader or in a cell charging and discharging machine. Then we will set the parameters. And after setting up the parameters, if we're going to charge and discharge the cell. After setting up the parameter, we're going to charge and discharge the cell. Then the cell will going to showcase us some graph. Based on that graph, we can able to extract the capacity of that particular cell, and based on the capacity we can say that this particular cell is having a good capacity, that particular cell we don't having a good capacity, so we cannot use them for the purpose of our battery pack manufacturing. In the cell sorting, generally we are testing the internal resistance of that particular battery pack, because internal resistance is very, very important. If some cells is good at capacity, but the internal resistance of that particular cell is very, very high, then we cannot use that particular cell. Right. So then we have something called as thermal management integrations. Right. In the thermal management integration, what we are doing, we are integrating the thermal system along with the complete battery pack. Once the thermal management is being done in the cell casing, then we are going to connect the battery pack. But then we're going to assemble a complete battery pack inside that casing. Right. Once that is being done, then we'll do the battery management systems integrations. Then we'll opt for a testing and quality control, and after all, we'll go for a final assembly of that particular battery pack inside the vehicles, right? So these are the various process, guys, and this is a capacity measurement. This is a constant current, constant voltage charging profile. First, we're going to charge the cell at very, very high current, and once the voltage will be reached to the maximum threshold, right? So the voltage remain constant, and we are going to reduce the current in an exponential manner up to the 10% of the cutoff current, right? This cutoff current will nothing but the 10% of charging current, right? Then what will be happen? Then we're going to charge the cell. Then we're going to discharge the cell at a constant current discharge. Then the graph will be fall below in this way, and it will measure the area below this curve, this area, right? Then we can able to calculate. This area is nothing but length into breadth, right? We can do the integration, but if we can do the length into breadth, then we can calculate what exactly is the capacity of this particular cell, right? Then we are doing some other profiles like pulse power incremental test profile. This is something where we are actually finding the OCV versus SOC characteristics, because we know OCV is something which is an open circuit voltage, right? And SOC, and if we're measuring the terminal voltage of a cell, that is not an OCV. If you're going to charge the cell and if you keep the cell for 2-hour rest, then the voltage what you will get, that is nothing but called as the open circuit voltage. So OCV versus SOC profile is very, very important, because OCV versus SOC profile is very, very important. Why it is very, very important? Because that will help us to algorithm the battery management system as far as our need is concerned. Why? Because if we don't know the OCV versus SOC characteristics, then we cannot predict at what percentage, what is the state of charge. Then BMS won't able to calculate that particular OCV, and ultimately BMS won't able to decide which is safer limit, which is not a safer limit, and ultimately our BMS will fail to perform any kind of operations or any kind of task. Right. So that is why we are using the pulse current incremental test, or we are also called them as. Okay, so if you connect this particular endpoint with a continuous graph, so we'll get something called as OCV versus SOC characteristics. You can see this is nothing but the time, right? So this is nothing but the pulse current which we are giving to reduce the voltage, and this is nothing but the charging time. So this test will take nearly around 15 to 20 days in minimum, right, to calculate this OCV profile. It is also called as HPPC test, which is hyper pulse power characterization test, right? So this is the end of my PPT, guys. Okay. If anyone have any doubt, you can do let me know. Any doubt anyone have?
Sir,
Yes.
you just mentioned like open circuit voltage is OCV is not the terminal voltage of a
Yes.
battery.
Yes.
But
Yes.
it is the voltage of a battery when it is fully charged and after 2 hours.
Yeah, actually what is happening, let's suppose we are actually charging the battery pack, and once after charging we'll suddenly take up the battery pack and try to measure the voltage by the help of a multimeter. Whatever we are getting, that is nothing but the terminal voltage. And terminal voltage, it is nothing but OCV minus dynamic voltage, OCV minus dynamic voltage minus some internal resistance drop, right? So OCV is some higher voltage, and in order to come to that higher voltage, we have to wait for some minute, because there is some internal chemical reaction is being happening which stabilize the internal reaction of it. That is why it will measure the cell terminal voltage after charging, then you will find that that is called as terminal voltage, that is not an OCV voltage. But after 2 hours, means that is the minimum time standard which industry is following, but that is not after 2 hours. 2 hours is the standard. It can be go up to 4 hours, 5 hours, 6 hours as well in some cases of cell, in some chemistries of the cell, right? So it will standardly take the 2 hours, means again that is not written in any book as industry is following. It will standardly look for that after 2 hours, and it will try to measure the voltage across the cell. Then the terminal voltage is equivalent to the open circuit voltage, because after 2 hours the dynamic voltage and internal resistance drop will be 0. And at that position, the terminal voltage is equivalent to the open circuit voltage, which is generally higher than the terminal voltage. Getting? But 2 hours is not a standard. It is what I mean to say. It is more or less we are taking as far as industry is been concerned, right? I had even see in various IITs research labs, they used to take something around 3 hours just to stabilize the voltage up to a standard level.
But sir, in the testing, while the estimation of SOC versus OCV versus SOC, how does that instrument measure then OCV correctly? Since it's a continuous process of charge.
Yeah, you are watching this particular graph, which currently I have, right? But currently I had shown here.
Yes, sir.
We are actually discharging the graph. We are giving a pulse current to discharge. Then you can see this is the constant time interval. This is nothing but that 2 hours of rest time which we are providing. After 2 hours, then we have to reduce it with a pulse current. Then we have to wait for another 2 hours. Then we have to reduce it up to up to certain things. Then we have to wait for another 2 hours, right? So if we'll do this thing, the end point of this means after 2 hours, this is the end point. This is the point where the voltage is being stabilized, and this is the point which is called as OCV. So you have to give a pulse current. That is why it is called as pulse current incremental test profile. That is why it is called as hyper pulse power characterization test. Getting? So this pulse you have to give, and for that you have to parameterize the particular because whatever the charger and discharger you have to make a parameter setting on the charger and discharger, and based on that you can, because there are the parameter setting. If you set the parameters for multiple times, then the machine will take care of based on the need of yours. Right? This kind of profile we are generating. That's why it is called as pulse current incremental test profiles.
So that time on the x-axis is in days, isn't it?
Not days, 2 hours.
Okay.
Means you can see, for example, you can see over here.
So in hours,
yeah, you can decrease. For example, you can decrease at every 10%. For example, you are currently 100%. First, you will completely charge the cell to 100%. You will give a pulse current and decrease up to 90%. Right? So you will stabilize it for 2 hours. Then you will get certain profile. Then after 2 hours, again you will give a pulse current and decrease it up to 80%. Then you will decrease it up to 70%, then 60%, then 50%, then 40%, then
fine, sir. Got it.
So you can get 2 hours. So likewise, you will get something 2 into 24 hours is being required for performing this test. This is for just discharging. Then you can go for charging as well. So if you go for charging, this is nothing but something which is called as. But here you can get only at 100% what is the charge, only at 90% what is the charge, only at 80%. You can even fine tune it at 100%, at 99% what will be the, at 98%. So it will again take a lot of time. That's why I told you that this particular thing will take huge amount of time in order to perform any kind of. That's why OCV and SOC is very, very dynamic thing to be doing.
So one more question.
Yeah.
A bit different apart from this topic, but related.
Yes.
While we're charging a battery, any typical electric battery, let us say, we are charging it at let's say 2C rate and discharging the same battery at 2C rate. Charging and discharging is both at the same C rate. In what condition, while in charging or discharging, the internal heat generation will be more?
See, whenever I'm talking about you are constant fix the particular C rate up to 2C rate. So see, During the charging, I can tell you, for example, if I'm talking about the vehicle, electric vehicle application, charging it is in the hand of a charger. That charger can able to charge it with constant current and constant voltage profile, right? So you can able to maintain that 2C. But during the discharging, you cannot maintain because that is more of dynamic. That is depend upon your drive cycles, means how you will going to drive your particular vehicle. That's why during the charging, you are going to generate huge amount of heat. During the discharging, you are going to generate huge amount of heat in that scenario. Right? Because discharging is something which is more of dynamic compared to charging, because we cannot charge particular cell. Charging, discharging is never be our concern, because discharging is something which the customer will be do based on his drive cycles. You will speed up the vehicle, then the discharging will be different. You will slow up the vehicle, then the discharging will be different. So at different condition, you have going to want different discharging method. But charging is something which we can fix. That is CC and CV. Every charger in the India or even in the foreign, they are following the same profile, that is CC and CV charging. Right, but as far as discharging is been concerned, it is not a dynamic. We are saying 2C and 3C, but it is a dynamic thing. It is not a constant we can do. We cannot never discharge the cell at a constant rate. We can do it in the practical.
If we do it in the laboratory with the aid of certain instrument.
Yeah, in that case, during the charging, you will get a lot of heat generations is being there compared to discharging.
Okay, fine, sir. Thank you.
Okay, any further doubts, guys? Any further doubts from any members? Because we had ended our sessions. Let me quickly look into this. Jitendra Chaudhary, actually memory effect is something where the battery will memorize the conditions of charging and discharging profile. For example, if you will charge the battery at 80%, sorry, I will charge the battery at 20%, you will start discharging at 80%, and for multiple time I will do it. The nickel cadmium and nickel metal hydride battery will memorize that 80% is the full charge and 20% is the minimum charge. So they will, when you will charge up to 80%, they will understand that you had fully charged your battery. When you will reach to 20%, even though you have 20% life still remaining, they will be switch off your mobile phones. That is what there in case of batteries. Rupali Dharma, what will be the charging time? I'm not getting Rupali. Can you please let me know, because at that time I'm not able to see that screen actually. Okay. Yeah, if it is a C rate will be the constant, then the charging and discharging time will be remain same. There will be no deviation if the C rate will be constant. But if the C rate will be different, it will take something different time. For the same, yes, Shivam has correctly mentioned that if the C rate will be same, the charging and discharging current will be same. If the C rate will be different, again the charging and discharging will be different. Yeah, Rupali, definitely. It will going to give a huge impact on the grid. I'm just actually giving you the examples, but the battery which you had shown, that is LiPo batteries, which is used for the drone applications. For the grid applications, that kind of huge current is never been flow, right? Because in grid current, you have a lot of things comes into action. Yeah, definitely. We are not going to use that much of high current in order to charge a battery pack. That is very, high current. That if you use in case of NMC will burn. LFP may sustain, but NMC may burn. Right. So with this, we are ending our, session, guys, as we are exceeding huge amount of time here. So any further doubts or any further query, anyone have, please do let me know. Any further doubts, any further query?
Sir, वो HPP कौन सा टेस्ट था वो I forgot.
Both are hyper pulse power characterization test.
What test perform correctly? What equipment do we need to have?
We need to have a cell charger and discharger.
So that 8 channel test cell charger.
Yeah, you can go for 8 channel. We can go for a 4 channel. Whatsoever.
Okay, fine.
That is been required along with they have a software to perform those parameters, and based on that only we can do that particular HPPC test.
All right, sir. And I just want to give a compliment. It was a wonderful session, sir. I haven't seen such a detailed explanation about the battery.
Yeah, thank you, because it is a very 2 hour session. So, stretching all the things is very difficult. So I had covered at that much of pacing rate, 2 hours has been concerned. If there is something which has been discussed, so I'm really apologies for the same.
No, sir. Everything was like as far as I know, everything was like perfect. Wonderful, sir. I'm really happy with the session and eager to know about few more sessions, if any such session you are arranging in coming future.
Thank you, sir. Thanks a lot, people. Yeah.
Hello, good afternoon, everyone. I'm audible.
Yes, sir.
Hello. Okay, so how was the session? Hello.
Yeah, hello, sir. I just like appreciated the session, the speaker.
Okay, thank you so much. So before we end, I just want to say that the EV industry is coming in the future. So for the same, we have launched the AICT approved master certification course in electric vehicle technology, which is designed for the students who want to move from theory to the real industries. Meanwhile, working on battery pack designs, BMS, battery controllers, or I can say communications or DV integration, to making the students or the professionals job ready. This course is not for everyone. It's only for the students who are serious about the building a strong career in the electric mobility. So those who are interested can register. I'm sharing the Google form link in the chat now. Just register. Once you apply, our team will personally connect you and guide you through the next steps. Is it okay to everyone? Hello.
Fine, sir. Fine. Good.
Okay, so I have shared the Google form link in the chat box. Just fill the form. Our team will connect you regarding how you can proceed with the same along with the certification course, and the certificate will be globally valid for all of you, and it will be approved and restored by the ICT itself. Is it okay to all of you? Hello.
Yes, sir. Fine.
Okay. Hello, Prabhat. If I talk about the course phase, so as it is a globally certified and it is with the collaboration with AICT, so you can check on the AICT website as well as on the ISI India website. The course phase is 40,000 rupees, but you can partially pay 6,600 rupees on the no-cost EMI basis, or 6,000 directly to the ISI India account as well for this next 6 months. And the classes will be on Saturday, Sunday only. And it will be live classes. And if I talk about the hands-on training, it will be conducted to the nearby labs. Is it okay? Any doubt to anyone? Okay. Now, yes, also you can continue with this.
Yes, sir, I'm done with my PPTs. If anyone have any query or doubts,